Okay, so most of the exercises in this section are very routine. So you have exercises 1 through 8, which are just computation. It instructs you to find the curl and the divergence. So I do encourage you to do the odd problems. Then, of course, go to the back of your textbook and check that, in fact, you've got the correct answer. And similarly, do 13 through 18. They're all very similar. Well, in this video, we're going to do one exercise, which is number 20. Now, many of the exercises after that are, I don't want to say they're beyond your ability, but they just don't, they're more abstract. And I think that we're going to get more out of this course if we focus on calculation, very concrete calculations. But there is one exercise I really like because it's going to use one result that often is not discussed in this course, but it is actually very nice. So this result says that the divergence of the curl is equal to 0. So the proof of this is very easy, and it's on page 1147 at the top of it. But basically what it's going to use is Clause's theorem, and a lot of terms are going to cancel. So you can just easily apply that. Okay? And you'll see that the divergence of the curl of f is equal to 0. So it's very straightforward. You can check the proof. Okay, so there's a question, problem 20. It says, is there a vector field G on the three-dimensional space such that the curl of G is equal to x, y, and z? Explain. So the haphazard way to do this problem is to assume that such a function exists. Okay? You say, well, if it exists, G is equal to P, Q, and R. I don't know what P, Q, and R are, but I'm going to do the calculation, apply the apply that to both sides, do your calculation, and then set the first coordinate equal to x and y and z and all that kind of nonsense. Okay, that's too much work. I like to keep things simple. Okay, well, let's see. So the answer is no, there is not. So let me give a reason why there isn't. So suppose there were. Then the divergence of the curl of G should equal 0, right? By this result right here. But the divergence, so we're assuming the curl of G is equal to this. So we're trying to find G such that the curl of G is equal to x, y, z, okay? So suppose there were such a G, such that the curl of G is equal to x, y, z. Then the divergence of x, y, z should equal 0, since those two are the same. Well, what is this? Well, this is equal to, remember the definition of the divergence, it is the first coordinate, take the derivative of that with respect to x, plus the second with respect to y, plus the third with respect to z, add them all together. So this is going to be x with respect to x, plus y with respect to y, plus z with respect to z. And this is going to be 1 plus 2 plus 3, so therefore 3 equals 0, but 3 does not equal 0. So this is a contradiction. Okay, so it could not be the case that there exists such a function or such a vector field G that satisfies that. So the answer is no, and that is why. See you in the next video.